Darrell Wallace, Manufacturing Technical Fellow for BlueForge Alliance, and I'm joined here today by Brad Johnson from ARIS Technologies. Brad, thank you for joining me.
Thank you for inviting me.
Okay. So, tell us a little about what is ARIS? What does ARIS do?
I answer that question a lot, and oftentimes I start off with explaining that ARIS is actually an acronym, stands for Automated Robotic Inspection System. So following up on that, we basically focus on non-contact metrology, so utilizing many aspects of 3D scanning, putting them through an automation process, whether that be through robot or other automation, hopefully to help the end customer make a better product.
Okay, so these automated systems, how much of that, what part is the ARIS technology, what part are you buying and integrating?
Yeah, so ARIS is focused on kind of making the whole process easy to use. It's a pretty complicated technology. You got laser scans, you got robotics, you have all these things, and so ARIS' core focus is to write our custom software to make that easy for the end user, not only the end user but also the management team that can review those results. So all of the communication between the devices, usually it's a robot, a 3D scanner, safety equipment, other automation, and an inspection platform software. So ARIS basically controls all of those things as one kind of wrapped up single user interface, and that's how we put the system together, and it's been pretty successful so far.
Okay, so you mentioned a couple different types of sensing and inspection technologies. You mentioned vision systems. I think, what are the various inspection technologies that you are able to integrate?
Yeah, I have a pretty strong background in the 3D measurement world, going back over 20 years with one of the first systems out there through Konica Minolta. So we use 3D laser scanning, structured light, infrared, photogrammetry. Those are all non-contact measurement tools that we use. Following up on that, from a robotics perspective, we use a number of robotics manufacturers, but both industrial and collaborative. The latter in collaborative has been really interesting recently, and it lets the user get in and interact with the system without the need for high-end safety systems or the danger or worry about getting injured.
So, the collaborative is certainly exciting because it lets the user interface directly. Also, I think reduces some of the cost of the safety systems that would be required. I'm curious, cost isn't always an issue. Robotics are usually expensive, sensing is expensive, automation's expensive. When does it make sense for a customer to use a system like yours?
We usually go in and look at some sort of an ROI with the customer. What we usually find is that the non-contact approach is actually cheaper than the way that they're currently doing it. Sometimes that's a little bit of a challenge to overcome early on, but meaning that people don't realize that. I'll just pay an inspector to sit out there and use his gauges and whatever. And then what they find is the amount of hours and time that go into that, not to mention the bad product that sometimes goes out. So usually we find that if you sit down and look at it, it'll be a cheaper solution than likely your current inspection process.
I assume there are automated and autonomous systems. Are you more automated or more autonomous, or?
We do both. I would say the autonomous is usually defined as no human interaction. So once we set up the system the first time with a particular part, it does become autonomous, because once we program the robot or the user programs the robot, from then on out you're basically just hitting play and letting the system do what it does. Additionally though, a closer step to full autonomy is that we are creating and have created the ability to just identify a part, set a part on a table, basically evaluate that through a technology, maybe a lower time of flight sensor or photogrammetry, identify a low resolution model, and then use that low resolution model and then program the plan for the robot to come in with a higher resolution. So we've got that completed. From the software side, the inspection, so that's the scanning side. From the software side, which is the once you get a scan data. Now you want to basically compare that back to what you're trying to achieve. And that's a little bit more challenging depending on the end user. Luckily, the industry is very much going to embedding product manufacturing information, PMI, into the CAD model. So we're seeing a lot of our customers that are already doing that, and the ones that aren't doing it are talking about doing it. And as that technology gets embedded into the 3D CAD, which we import, then it can become pretty autonomous, even without any user interaction, because the alignment data, the inspection data is all encompassed in that 3D CAD model, which is one of the areas where we start with. So definitely moving in that direction, and I think as the industry, catches up or completes that process, I think we're ready.
So am I hearing you right that we're getting to a point where one-off inspections autonomously are achievable? Is that today?
Yeah, we're doing that right now. With I would say it's in a beta level, working with a lot of 3D printing companies and things of that nature, which are indeed built on one-off opportunities. So we're doing that right now and kind of perfecting it, and I see that being the way of the future.
Where are you in terms of, you're talking about it, it's kind of in a beta. What are the hurdles to maturing that technology? What are the technical barriers that are making that be beta? What needs to improve to make that more robust? And then what are the barriers to adoption? What does industry need to have happen for this to be a cost-effective and kind of ubiquitous approach?
Yeah, I'll start out kind of with the first one. So I think sometimes right now, if we get a CAD model, which is the master model that somebody's trying to compare to, if the PMI data or the inspection data is not already included in that, it comes along with the 2D drawing. My people can certainly take that 2D drawing and put that information into the 3D CAD model, which then we could kind of complete that autonomous step. But I guess our users, putting that data in, eliminates the autonomous side of that. So I would say one of the barriers is getting the industry standardized on putting that manufacturing and inspection data into the CAD model, into that master model. And then I would say, some of the barriers, obviously cost, CapEx is always something that, is hard. You got to budget for it and plan for it. So I would say they are expensive systems. I mean, we have some systems that start down in the $250,000 range, but an average system, it's not uncommon to see $500,000 or well over $1 million. So that's a pretty big spend for a lot of the customers out there. So planning ahead of that, looking at the ROI and those things are definitely some of the, I'd say adaptation as well. So we got a lot of metrology people out there, a lot of inspection people out there that have been doing something a certain way for many years, and it's not always easy to convince them that there's a better way or that this way even works. Years ago when 3D scanning came out, it was not as accurate, not as tight resolution, so some people maybe tested the waters a little bit and found out that the accuracy wasn't there. It's come around now to where it's quite honestly, in most cases, more accurate than CMMs and the other processes. But I still think there's a workforce training that has to happen so that person trusts it, understands it, and sometimes it's intimidating. You go from somebody holding calipers and micrometers into watching this robot move this laser scanner around, and so yeah, I think there's a little bit of industry acceptance. And
as we look at technologies that help move from automation to autonomy, one of the things that inevitably comes up is AI. To what extent is AI part of what you're doing, and how do you see that playing in the future?
Sure, it's a big focus for where we're going, and a big focus for what we're planning on implementing. We are currently have a number of projects that we are utilizing AI. One of them is an inverse modeling approach that we've used, which is basically to help some of that low volume, one-off 3D printing stuff, so that we can quickly implement that technology. We've used a lot of AI so far for welding inspections. We've done some projects where looking at, hey, is there a gap present? Everybody thinks, robotic welding is great, and it is, but if the presented model doesn't match what the robot thinks is there, then that creates problems. Most of the robots today have something called seam tracking, so they can look at it, but that doesn't help you identify, hey, is there a millimeter or 2 millimeter gap there? So we basically implemented some AI on a project. It worked out well to basically identify, hey, how big is this gap? Is there a gap there? How does that affect the end result? And then we could change our tool path live, not only our tool path, but also the welding settings to basically get your best end result. Even adjusting the path that the welder will take. If you've got 20 welds on a project, we can hop back and forth and we used AI to kind of drive that path. It had a really good result. So that's one of the examples. But we're definitely we see AI as a big part of our future and the whole autonomous scanning future.
Did I understand correctly when you were talking about that you are doing the inspections and then feeding that information back to the welding process to adjust the process?
Yep. Yeah, we kind of call it a closed loop process. We're obviously looking at doing that with all kinds of processes, CMM or CNC machines and such. But yeah, currently right now we have applications, automated robotic system out there that we're basically getting live data from the part, evaluating that data, and then using that data to drive the welding robot process. So.
In terms of your industry, this automated metrology, I mean, you're not certainly the only ones in this space, so could you talk a little generally about where that industry is headed? What's over the horizon or near term what we can look forward to in automated metrology?
But a lot of the people that are out there are the scanner manufacturers themselves, or in some cases the robot manufacturers. That makes them be very focused on a one-stop solution. If it's a particular scanner manufacturer, he's not going to integrate somebody else's scanner, even if his scanner's not the right job. Same with robots. There's a difference between robots, and so I think one thing that sets ARIS aside is that we're kind of autonomous. We're not making the robots, we're not making the scanners, we're not making the inspection software. We're just bringing it all together. So that's one area that I think sets us aside. As far as the industry goes, I think some of the limitations that are out there in non-contact are deep hole scanning as a general rule. This non-contact measurement usually can go about as deep down into, say, a hole as the diameter of the hole. So if you've got a 10 millimeter diameter hole, you're only going to get 10 millimeters. That hole might be 30, 40, 50 millimeters deep. It might be a through hole through the whole part. So those are some areas that the industry is looking on how to achieve shiny. We've come a long ways. Shiny parts, machined parts used to be a very big challenge, but now a lot of most of the scanners out there are able to handle that without any preparation, surface preparation or whatnot. So, and I would say, touching back on an earlier point, that the ability to use this, not be intimidated by the technology, and be able to have it out there on the shop floor and have a machine operator. Most of our systems, we have the machine operator, who might be making the part or machining the part. He comes over, sets the part down on our system and hits play and runs it. So I think getting the user base out there is really important, and getting them to feel comfortable of this, high piece of technology and that they can run it.
So as we think about the future of automated inspections and metrology, what is that going to mean? How is that going to affect the American industrial base, and of course, given our particular focus, the submarine industrial base? What do you envision as being the impacts of increased adoption of automated inspection systems?
Yeah, we've had the opportunity to work pretty closely with a number of government facilities, and we're focused on the maritime and submarine industry, and hopefully have an opportunity to work with you guys. Implementation of this technology, will speed up the manufacturing process, because, right now, a lot of the industrial base out there is quite honestly behind the times. They're using, old technologies, and this technology, that adaptation of this technology and equipment will definitely speed up the overall process. I think it will also save money, because time is money, and I think meeting your time goals, will save money. And then I think as well, some of the workforce out there is, this allows you to have a worker or a machine operator be able to actually come in and inspect his own parts. So I think thinking of submarines and and ships and things of that nature. There's a lot of welding, a lot of big pieces of steel that go together, and I think being able to get results and answers on whether that's a good weld or whether that part is in the right place and everything is going to save a lot of time, save a lot of money, and increase the ability to produce the units that need to be done for our safety of our country.
What are you excited about? What's new? What's coming down the pike here for ARIS?
Sure, I might have got a little twinkle in my eye earlier when we spoke about the ARIS inverse modeling software, when we were talking about autonomous inspection and the need. A lot of our customers, if I walk into an automotive plant, which I do, they're producing thousands of parts a day and they're inspecting one per shift, and so that's a home run for us to go in there and program up a part that they're going to inspect 100 times a day. But for the people that are only making one part a day or maybe 100 parts a day, but they're different, each one is different, I think the ability, the autonomous scanning and a piece of software we've been working on, which is ARIS Inverse Modeler, and what that basically does is you input a design model into your, let's use 3D printing as an example. So you put in a design model in your 3D printer, and your 3D printer produces it. And then the question is, how well did it produce it? And inevitably, whether it's a micron off or 100 microns off, it won't be perfect. And some of that error is sink and warp and twist. There are things that are hard. Most 3D printers have uniform scale, so you can have an X scale, a Y scale, and a Z scale, but addressing warp or sink or twist and things of that nature is not easily done in a 3D world. So we're pretty excited about the adaptation of the AIM software that we're getting out right now and being tested. One of the struggles historically for 3D scanning has been, I mentioned, deep holes or areas that you can't see. Most of the non-contact scanning that's out there is based on some type of a light projection and some type of a camera that captures the shape of that. So if you can imagine, going down inside of a hole or a small area like inside of a submarine, sometimes those become challenging areas, and we're doing a lot of research right now and development on deep hole sensing and confined space sensing. So those are areas that are pretty excited to me, and just generally I like making all of our customers' product be better, higher quality and produce it quicker.
Well, we certainly are excited also to learn about opportunities to leverage automated inspection to support the submarine industrial base. So looking forward to seeing how that turns out. Brad, I want to thank you for joining me today. Appreciate you sharing your insights and letting us know about what's going on in automated metrology.
Well, again, I appreciate you having me. It's been a great time.
Thank you.